Good morning to all my dear viewers. First of all, have a look towards the new topic, area of parallelogram and triangles. You all must have been thinking for a while that this would be a difficult one, but it's an important and interesting chapter as well. Basically, this chapter is important and very useful for the students of class 9th. So first of all, we're going to look towards the property that would be basically facing. So our very first property is median divides the triangle in two equal parts as well as in two equal areas. According to this, there is a triangle XYZ. Then if a XM is a median, then it would be dividing the triangle into two equal parts in XYM and XMZ. So the triangle XYZ is divided into two parts, XYM and XYZ. So our second identity is parallelogram on the same base and between the same parallels are equal in area. If there would be two parallelogram ABCD and ABEF, then if their base would be equal or same AB and parallels FC, then the area of parallelogram ABCD is equals to the area of parallelogram ABEF. In our third identity, it says that if triangles and parallelogram are on the same base and between the same parallels, the area of triangle would be half of the area of the parallelogram. If ABCD is a parallelogram and ABE is a triangle on the base of the parallelogram and the triangles is under the same parallels of the parallelogram, then the area of the triangle would be half the area of the parallelogram. If we suppose the area of parallelogram ABCD is 10, then the area of triangle ABE would be 5 because the area of the triangle would be half the area of the parallelogram. Now we come towards the last identity. Triangles to the same parallels and between the same base are equal in area. If we see the triangle ABC and ABE and ADB, these three triangles are under the same parallels and on the same base AB. Then it shows the triangle to the area of ABC is equals to ABD as well as to the area of AEB. So now we have learned towards the four identities that are if the triangles and the parallelogram are on the same base and between the same parallels, the area of the triangle would be half of the area of the parallelogram. Then the parallelogram on the same base and between the same parallels are equal in area. Median divides the triangles in two equal parts as well as in two equal areas. Triangles to the same base and between the same parallels are equal in area. So now we are to start some questions. So we must come to our very first question, that is, if EFGH are respectively midpoints of side of ABCD parallelogram, then show that EFGH is equals to half of the area of ABCD. We have been showing the figures, and then first of all draw HF parallel to AB and which is parallel to DC. Now HF is parallel to AB, HF is parallel to AB and AH is parallel to BF because it has been given it's a parallelogram. So we have proved that ABFH is a parallelogram. Again HF is parallel to DC, HD is parallel to FC. So HFDC is also a parallelogram. And then GHF is equals to half of the area of parallelogram ABFH because triangles to the same base of the parallelogram and parallels are half of the area of the parallelogram. If you see towards GHF, you must be thinking that this triangle would be half of the area of the parallelogram ABFH as I have discussed in the property. This is our equation 1. In equation 2, HEF is equals to half of the parallelogram DCFH. It's an equation 2 because again the triangle to the same base and between the same parallelogram are equal in area. Then it would be equation 2. Then we must have been adding both the equations. So after adding equations, we got that GHF plus HEF is equals to half ABFH plus half DCFH. Then if we add up these things, we would be getting EFGH, and then we must have taken half common. Then we got half ABCD. So we have proved EFGH is equals to half the area of parallelogram ABCD. So our second question is, P and Q are the two midpoints lying on the side DC and AD respectively of parallelogram ABCD. Show that APB is equals to BQC. AB is parallel to DC because it's given that's in parallelogram. So ABP would equals to half of ABCD because triangle to the same base and between the same parallels of the parallelogram would be half of the area of the parallelogram. And this is our equation 1. Our equation 2 would be QBC is equals to half of the parallelogram ABC because area of triangle would be half if there would be same side and same base of the parallelogram. So this would be equation 2, and if we see equation 1 as well as equation 2, we would be finding that our RHS is same. So if our RHS is same, then automatically our left hand side would be also same. So hence we have proved ABP is equals to QBC. Now we shall start with our very third question, which says that if D is the midpoint of BC of triangle ABC and E is the midpoint of line segment AD, then show DEB is equals to 1/4 ABC. It tells that D is the midpoint of BC, which is given in the figure. Then AD would be the median on BC. Then as we know, median divides the triangle in two equal parts and in two equal areas. Then ADB would be half of ABC because AD is the median, and this is our equation 1. E is the midpoint of line segment AD, then BE would be median on AD. Then BED would be half ABD. This will be our equation 2 because median divides the triangle in two equal areas as well as in two equal parts. So BED would be half into half ABC. I have taken half over here because if we see in equation 2, which it is given ABD, and in equation 1 we know the value of ABD is equals to half. So we have replaced the values of BAD into half. So BED would be half into half ABC, which is BED 1/4 ABC. Hence we have proved it. So now let's check out with our last interesting question that says, in the figure AP is parallel to BQ and it is parallel to CR. Then we have to prove the triangle AQC is equals to triangle BPR. And now given, and in the figure it has been already given that AP is parallel to BQ and it is parallel to CR. So then APBQ and BQRC will become the parallelogram. And so ABQ is equals to PQB, which is equation 1, because triangle to the same base and between the same parallels are equal in area. This would be our equation 1. In our very second equation, we have proved that BQC is equals to BQR. BQC is equals to BQR because if you see that this both are both the parallel lines. So triangle to the same base and between same parallels are equal in area. This was our equation 2. If we add equation 1 and equation 2, we must have been getting ABQ plus BQC is equals to PBQ plus BQR. and if we add them, ABQ plus BQC, then it would be AQC, and PBQ plus QBR, it would be PBR. Hence, we have proved AQC is equals to PBR. So, my dear friends, I am finished with this video. First of all, I just wanted to say, if you wanted to like this video or subscribe, it's your own wish. But if you have any doubts, then please do mention in the comment box. Thank you.